Okay, we're in section 5.1 where we're going to talk about mid-segment theorem and coordinate proof. The first thing we're going to take a look at is the mid-segment of a triangle. If you look at the picture here, we have line segments that connect the midpoints of the two sides of a triangle, and if you look at it, every triangle has three mid-segments, which makes sense because three sides, three midpoints, and so that green triangle comes from all three midpoints from the corresponding sides, or from the opposite sides. What we can take from that is we have what is called the mid-segment theorem. So if you were to look at this one triangle here specifically, it says the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as its side. Sounds like a mouthful, but it really isn't that bad. So if you were to take a look at this and say if AM equals BM, which basically is saying that point M is the midpoint in this portion of the triangle. So I'm going to erase that. And then we can say that CN is equal to BN, which is the point N is the midpoint of that particular side. Okay. And erase that. So, and if they're saying that if MN is parallel to AC in this triangle, we can make the conclusion that MN equals half the distance of AC. You could also say, or 2 times whatever the distance of MN is going to equal AC. Okay? So if we were to look back up at this little triangle here, this distance here is actually half the size of this line segment. Same thing here. This line segment here is half the size of this whole line segment. And again, this line segment here is half the size of this line segment here. Okay? So with that, we can solve some problems. So the example says that DE is a mid-segment of triangle ABC. So we have to find the value for x. So as long as DE is a mid-segment, we know that this is parallel to this. So what we're trying to find is x. So since we know that DE is half the distance of BC in this case, I know that x is 22 divided by 2, which gives me 11. Looking at the second one, again, I'm given DE. I know that BC is twice the distance, so that means it's 18 times by 2, which gives me 36. And this one here, all it knows is a mid-segment, so that means that point E is a midpoint, and so these two side lengths, actually, these two portions are equal to one another, so that means x is 17. And then finally, looking at this last triangle here, you can write this one of two ways. You could say that it's 2 times 3x minus 5, because I know that the mid-segment is half the size, so that means I have to multiply it by 2. Or you could also write 3x minus 5 equals 4x plus 2, and the whole thing's divided by 2. So I just chose to use this one. If I distribute the 2, I get 6x minus 10 equals 4x plus 2. I'm going to subtract 4x to both sides, so I get 2x minus 10 equals 2. Add 10 to both sides, so I get 2x equals 12. And then finally dividing both sides by 2, x equals 6. Okay. Next, they want us to find or place a figure in a coordinate plane in a convenient way. It says assigned coordinates to each vertex. So it says in a convenient way. So there are, an array of different ways that we can solve this, but the convenient way, which makes it kind of a hint, which means you're going to place one point at 0, 0 to kind of help you out. You know, it makes the combinations much less, and it will help you out when you're solving for these types of problems. First off, they want us to make or find the coordinates of an isosceles right triangle with leg lengths is 7 units. Now, if you remember back when we talked about classification of triangles, isosceles triangles talk about their sides, and isosceles triangles, if you remember, have at least 2 equal sides. Right triangles, on the other hand, are talking about classifications of their angles. So that means that it's going to have to be a right angle also. So it's got to have 2 equal sides, and one of them has to be 90 degrees. So right off the bat, I'm going to put 0, 0 to help me out. And they're telling you that the leg lengths are 7 units. So I'm going to go upward 7 units. 1, 2, 3, 4, 5, 6, 7. And the coordinate of this is 0, 7. And then to the right, I'm going to go 7 units as well. 1, 2, 3, 4, 5, 6, 7. And the coordinate of that is 7, 0. So if I were to draw a line here, draw a line here, oh, this gives me 90 degrees. This is the same as this. So this satisfies all of the items that are in the description of the problem. I have a right triangle, I have 2 congruent sides, and the coordinates for this one that I have chosen are 0, 0, 0, 7, and 7, 0. You could have also went to the left, or you could have went down, and that would have been a convenient way to put it as well. But, you know, this is the one I chose. Okay. Looking at B, it says square side lengths is 5 units. All right, right off the bat, like I said, use the hint, but 0, 0 is 1 point. A square is a quadrilateral, all congruent sides, and all sides are 90 degrees. So easy enough. I'm just going to go 5 units to the right. 1, 2, 3, 4, 5. This is going to be 5, 0. I'm going to go 5 units up from there. 1, 2, 3, 4, 5. This is 5, 5. And then finally, I'm going to plot a point here, which is 0, 5. It fulfills all of the items in the description of the problem. All the sides are equal, and each angle is 90 degrees. And the coordinates that I chose were 0, 0, 0, 5, 5, 5, and then finally 5, 0. Now, before I get to the next page, I talked about this in class. There are going to be some problems where they don't give you specific unit measures, where they're going to give you variables where they want you to solve. So another example would say, like, what if you had a rectangle with length equaling A and width equaling B? All right, they don't tell you what it is, but if you were to say draw out a XY coordinate, you could still do the problem and help you solve it. So first off, I want to put 0, 0 as my 1 point, and then I'm going to plot a point here. All right, I'm going to use the length. Okay, so with length needing to be the value of A, the coordinate here has got to be A, 0. Okay, going here, this has got to be the width. The distance from here to here must be B, so this coordinate must be 0, B. And then finally, because of the description of a rectangle, it's all angles must be 90 degrees. This coordinate here must be A, B. So if you had some kind of situation like this, my coordinates would be placed as 0, 0, A, 0, 0, B, and finally A, B. Okay? So hopefully you don't get confused when you stumble across some coordinates that have some variables also. kind of like what we have here, okay? They want us to find the coordinate of the red points in the figure. So I need to find the coordinates of point D and points E. Now they do give us some information in this. They find that points A and B make the midpoint for D, and the points C and B is the midpoint of E. So we do have a formula that's going to help us out, which is the midpoint formula. And if you remember, the midpoint formula is x of 2 plus x of 1 divided by 2, comma, y sub 2 plus y sub 1 divided by 2. All right, whatever you choose to be your x sub 2 and x sub 1 and y sub 2 and y sub 1. It's not a big deal. So if I know that this point here and this point here is midpoint of D, I can say that D is going to come from negative 4h plus 0 divided by 2, comma, 0 plus 4g divided by 2. Negative 4 plus 0 is 0, so I get negative 4h divided by 2. This gives me 4g divided by 2. Solve it out. Point D is going to be negative 2h, comma, 2g. And then looking at the next one, again, we're just going to use the midpoint formula to help us out. So this becomes 0 plus 4h divided by 2, comma, 4g plus 0 divided by 2. This becomes 4h divided by 2, comma, 4g divided by 2. I divide both sides by 2. Point E becomes 2h, comma, 2g. Okay? And that's being able to use the mid-segment theorem and coordinate proof. Hope this helps. Until next time.